Okay, here's an opportunity for you now to try finding the volume of revolution between two curves. The question is, find the volume of revolution created when the area bounded between the curves below is rotated 360 degrees about the x-axis, and your two curves are y equals 4x squared minus 18x minus 1 and y equals 2x squared minus 7x minus 10. Probably take you about 10 minutes, and you might want to look back at the question I did just now as an example. Now's a good time for you to hit pause, have a go at this question, and then I'll put the solution up as soon as you're done. Okay, so you should have had an opportunity to solve that question. First thing I would always do is get myself a graph together so I know exactly what I'm dealing with. So in this case, I've put it together on GeoGebra. You could use your graphical calculator or just sketch it out depending on the shape, and seeing as it's a quadratic, it's not too difficult to do. This way you can decide which part is going to be h1, which part is going to be y1, and which part is going to be y2, and that's fairly crucial. Essentially, you are going to be rotating the area between these two intersections. So we're talking about this tick shape here that's going to be rotated. To avoid getting a negative answer at the end, it's very important that we integrate y1 first and then y2 and minus the volume of y2 from the volume of y1. If you do it the other way around, you'll end up with a negative answer, which you can take the magnitude of to give you a positive volume, but it's much more elegant if you manage to do it the right way around first time. So let's start off with trying to work out these 2 points of intersection. We'll do that by simply equating the 2 quadratics to each other. And then working with that to solve it. You should end up with 2 solutions. One is x equals 1 and the other one x equals 9 over 2. Once you've got your 2 solutions to these quadratics, you now have the limits by which you're going to integrate, but we've still got lots of work to do. We need to work out what y1 squared is and what y2 squared is. Remember, the formula we're going to be using, I'll put it down here so it's out of the way, is pi the integral of y1 squared minus y2 squared dx. To work out what y1 squared is, we need to obviously have decided which one y1 is and y2, which we've already done, and now just start squaring away. You should, after lots of very exciting mathematical manipulation, end up with 16x to the power of 4 minus 144x cubed plus 316x squared plus 36x plus 1. And with y2 squared, again some nice complicated algebraic manipulation, should end up with 4x to the power of 4 minus 28x cubed plus 9x squared plus 140x plus 100. We now obviously need to do y1 squared minus y2 squared and work out the difference, which leaves you with 12x to the power of 4 minus 116x cubed plus 307x squared minus 104x plus 99. Apologies, minus 99. Now you've got that, we're ready to start integrating, and we'll do that in the next video clip.